I was in Microsoft Word. Having done that, I wanted to say that this column is sorted. And I looked for some symbol. And I didn't find any. Later on, I was wondering if there was some symbol that you could use to indicate that the column has been sorted. I didn't find it anywhere. So I am proposing a symbol, a set of symbols actually. So after 20 years, this seems to be taking some shape. So in a table, we can view columns and rows as instances of the same structure, array. So a row is a horizontal array, a column is a vertical array. And the table is made of one or more arrays. Now there are 4 basic questions regarding any array, regarding this part. There can be several other questions as well. So this is an array of numbers. First question, occurrence. Does X appear in the array? Say 4. Does it appear in the array? Anyone? Quick. No? Okay. So what did you actually do? We looked at the first element, 37. That's not 4. Next, 11. Not 4. Next. You went on till you found 4. You did not find 4. You reached the end of the array. Then you declare that 4 is not there. So you had to scan the whole array. Next question, position. Where does X appear in the array? Say X is 3. Where does it appear? Quick. Second last. That was quick. Probably because you had seen the array for some time. Range. What is the range of values? So range is basically the smallest value and the largest value, just 2 numbers. 2 to 53, that's correct. But please note that it took you some more time. Okay? Overlap. How many values fall in a given range R? Say R is 10 to 24. Quick. No? How many values? 8. No, there is 11, 13, 17, 19, that's all. So the answer is 4. Okay? Now, we sort the array. Now, does 4 appear? 2, that's not 4. 3, that's not 4. Now the next number, if that is 4, you are done. Okay, that's not 4. 5, that's not 4. And now you know that you have already crossed 4. So anything on the right of 5 is useless. You need not look at it. So we have saved our time by making our task smaller, simpler. Position, where does 3 appear? 2, 3, second position. Range, what is the range of values? Now it's very simple. Just look at the first number, that's 2, the last number, that's 53. Overlap, how many values fall in this range? 10, 24. 2, 3, 5, 7, next is 11. So 10 lies between 7 and 11. And then I have to go all the way up to 11, 13, 17, 19, 23, 29. So 24 lies between 23 and 29. I made a mistake. So there are 5 values actually that lie between 10 and 24, not 4. So we see that with a sorted array, things were simpler to answer. And why was this? An unsorted array does not necessarily have a structure or order. So you have to scan the whole search space, which is in this case the whole array. If you sort it, basically you are establishing some order. With order, your search space reduces. So you have to do, your computation reduces. And that makes it more efficient. This is a fairly technical slide. I don't think we have time to go through this. Sorted versus sorted. So I realized that sorted has 2 meanings. One is that the array is in a state of sortedness or non-sortedness. The other is we apply sorting to an array, so we actually sort it and then call it a sorted array. Okay, so we need to distinguish between 2 meanings of sorted array: state, an array being in the state of sortedness, or the result of a process, which is an array to which sorting has been applied. This is something I defined, auto-sorted array. So let's go back. Here we have 2 things, state and process. Okay, suppose we apply sorting. What happens? It gets sorted. So the process of sorting has an effect on its state. Now you don't have 2 states, sorted and non-sorted. You have only one state, sorted. And the other thing is, if we apply sorting, if we don't apply sorting, the array could be in the state of sortedness or non-sortedness. You're with me? I'm getting puzzled looks. Okay, we'll see an example later on. Or maybe we can push forward and, okay. So this is some data, okay? Name, age, height, sleep hours, and place. So you can see that none of the arrays, none of the columns have been sorted, all are unsorted. Now if we sort this table on age, we'll get a result that it gets sorted on height as well. We sort it on age, we sort it on age. Then it gets sorted on height as well. Why did that happen? It happened because height correlates with age. So, if we sort, we can get another array sorted. The other thing is that we notice that the column for place is not sorted. So probably age and place are not related, not correlated. Okay? Now let me just go back. We were here. Okay. So auto-sorted array is an array that is sorted without sorting being applied to it. So that is something like a curious case. If you sort an array, you expect it to get sorted in the state of being sorted, but you have not applied any sorting to it, but it is still in the state of being sorted. Why is that so? So there could be 2 reasons. One is correlation. The array correlates with another array that is sorted. So in this case, as we saw in the example, the column for height was sorted because the column for age was sorted. The column for height was not sorted. We got it as a bonus. The other reason is sheer coincidence. We don't know why. It's not correlated, but it's sorted. Okay. So detecting an auto-sorted array might help detect a correlation. And this helps research. It helps you find patterns in the data. But to detect an auto-sorted array, a researcher has to be alert and intelligent. Who wants to be alert and intelligent? We would rather be dumb and lazy. So, there are tools for being dumb and lazy. One is to formalize the method. An advanced tool is to automatize the whole thing. So can we do that? We propose that to each array, we'll assign a label called a sort symbol, with the hope that these symbols will help us detect the correlation. So this is like a review of what we have already gone through. There is a variable called sorting applied. Its values are yes or no, sorting applied or sorting was not applied. And then we get a result. The array is sorted, either sorted or, wait. How does the pointer work? Sorry? Okay. Okay. So, if we do not sort, obviously the sort order could be none. There is no sort order. If we sort, it could be ascending or descending or non-descending. We'll shortly see the symbols for this, and non-ascending. But there is no symbol for any of these atomic entities. 7 atomic entities, 1, 2, and these 5. And there is no symbol for any of the 9 combinations. 10 into 5 would be 10, but one of the combinations is invalid, and we'll see why. And here we propose symbols for these. This symbol is a diamond. It is a combination of the less than sign on the left here and greater than sign on the right. Okay. Basically, when you sort either in the ascending order or descending order, and that involves comparing two elements A and B as A less than B or A greater than B. So all sorting is about less than or greater than. Therefore, the two signs. And this is a circle, which means sorting was not applied at all. Okay, so first go through the legend. SA means sorting applied, SO means sorting order, and CS is the composite symbol. So if we do not sort, then the array could be either sorted automatically, sorted on its own, or sorted in the ascending order, sorted in the non-descending order. This is less than or equal to. So you might have 2. So the array could go like this: 2, 3, 3, 4, 5, 5, 5, 6, so on. It's not decreasing. Okay. Similarly, it could be auto-sorted in descending, auto-sorted in the non-ascending order. Though this is the invalid combination. If you sort an array, then the sorting order cannot be none. It has to be sorted. If you sort an array, you will get some sorted array. It cannot be non-sorted. Then we have these symbols, corresponding symbols, sorted in ascending, sorted in non-descending order, sorted in descending, and sorted in non-ascending order. Now, how do we use these symbols? So, this is the data that is given to us. It's an unprocessed data, and we have not done anything with it. Name, age, height, number of sleeping hours, and place. Now, we apply sort symbols. So, since we know that nothing has been sorted, we just put, and we also check whether there is any sort, or is it already sorted. So, KN, if you look at name, KNAALP, not sorted. 652435, not sorted. Same for these three columns. Now we apply sort symbols. We sort the table on the column age. And we use this symbol because you have 5 and 5 here. So it's 2, 3, 4, 5, 5, and then 6. Once we sort this, we get a bonus. Height has been sorted. Okay? So height correlates positively with age. Yes? This one is sorted. Sleep hours are sorted in the descending order. Okay? Oh, sorry. Yeah. This is sorted in the ascending order. 86, 95, 103, 1110, 110. Oh, 109. I goofed. This is a mistake, but yeah, it should get sorted. I put some wrong values somewhere. Sorry? Yeah, let's assume it was 111. Nelson's number. Okay. Sleep hours got sorted because with age, as age increases, the number of sleep hours decrease. Okay. So we got these two arrays sorted, even though we had not actively manually sorted them. We had sorted only one column, and this is the kind of a bonus that we got. And we noticed that place has not been sorted. KTTVPS. Okay, so we have two results. Height correlates positively with age. They are not results, actually, they are two candidate hypotheses. We'll have to check them using statistics. And sleep correlates negatively with age. So basically, any of the symbols, there are names for these symbols. Here, less than, greater than, blah, blah. Okay, with any of those four symbols, it's one of the two cases. Either the array correlates with another array, or it is just a sheer coincidence that it is in a sorted state. Now, another thing that we could do is sort the table on not just one column, but several columns. Say, first we sort it on column A, then on column B, and so on. And this is so when we sort this, okay, so Kim has age 6, height 112, sleep hours 9, and so on. So when we sort it, Kim 6, 112, 9, 7. So basically the whole row gets sorted, goes up or down. It's not that the values are not independent. So when we sort this, scheme comes at the bottom, but these values are not getting sorted independently. Okay, so a table can be sorted firstly on column A, column B, and so on, and this gives rise to multiple keys for sorting, primary key, secondary key, and so on. However, there is no symbol to indicate sort keys. So we propose some symbols. These are the symbols. So if column A has been sorted, that is the primary key, we put key 1, then key 2, and so on. So primary sort key is key 1, secondary sort key is key 2, and inner sort key would be key n. Now, these symbols would aid several things. One is academics. They would help us detect correlation without doing the statistical processing. They are not detect actually. They would lead to the formulation of a hypothesis that probably one column is correlated. Table construction would be more disciplined and less prone to errors. So if we follow the discipline that if an array is sorted, we'll say explicitly with a symbol. If it's not sorted, we'll say that again explicitly. Table comprehension becomes efficient and clear. You don't have to figure out whether a row or column is sorted. The author would tell you by putting the symbols there. It would also help speech to text and in general accessibility, because if a table has sorted array or sorted column, there would be a sign which can be converted into some audio signal that there is a sign. It is sorted. Otherwise, it's just left to the reader to figure out that it is sorted. So we go for explicitly stating this. Since there is a symbol, it would also help LLMs for symbolic manipulation. And similarly, it would help extended versions of theorem provers. Theorem provers are not mathematicians, theorem provers are programs. So, and they do symbolic manipulation. So once we have a symbol, it is easier to do processing. These symbols are currently provisional. They are neither comprehensive nor complete. They are open to any sort of change, add, delete, or modify. They are Unicode based. This is actually not something ideal, because addition of a meaning to an existing Unicode character is not desirable. And still, this is the case with 14 out of the 16 symbols that we have proposed. And these symbols are, some of them are composite in the sense 2 or more atomic symbols are glued together. For instance, we saw this, okay. So here it's less than, that is one atomic symbol, and another atomic symbol is the circle. Yeah. So thanks TIG users group for giving me the opportunity to present this. Thanks for the team for their patience. I submitted late and then gave an update, but they still managed to accommodate all that. And thanks everyone for listening. And yes, yeah. Yeah, take this.
Hello. Yeah, I just wanted to add one or two things he missed to add in his presentation. One thing is the symbols. It's his idea. The symbols are specifically designed to facilitate an important aspect of tables. Here.
No, just
So let's say if we are discussing this symbol, it applies to an array, which is a column, which is a vertical column. An important idea is if we place this symbol in any of the two elements of the array, it gives us the relationship of being lesser than. So 86 is lesser than 95, 95 is whatever, so on. So all these symbols actually, for example, sleeping hours, this symbol, if you place in these two, it makes sense for all the elements of the array. So that is one thing he missed to mention. And the other thing is just like notice that we are very bad designers, so symbols don't at all look good, but that's something we tried for the presentation. So just ignore the aesthetic elements of it. Yeah, I just wanted to add these two things.
Yeah,
Thank you.
So these are provisional. Nothing is final. Yeah, any questions? Thanks everyone for listening. Thanks, Tech Resource Group. Any questions?
Yeah, thanks. Quite cool idea in my opinion. I have not a question, but maybe a suggestion. Given the fact that there was not correctly sorted, unsorted column, obviously in that particular example, there were the other column was both H5. So in some sense, if you would have ordered the things the other way around, it would have come correctly.
Sorry.
You ordered by age, right?
Yeah.
And then we got the height for free, but not quite because it was 110 and 109. If the rows Nina and Prill would have been taken the other way around, which was still doing your age sorting correctly, everything would be correct as you claimed.
Yes.
Now, what I was suggesting is to detect correlation, it might be an idea to have sort of nearly sorted, which might be something like using a tilde sign with a greater or something like that, indicating by some measure. I mean, you have to describe how much sorting should be to make that symbol work. But then you get something like saying this height column is not 100% sorted, but 95.
Yeah.
And that's your cutoff point or something. So having another sort of symbol level gives you nearly sorting.
Yeah, thanks for pointing this out. I was wondering why that error occurred. Now I know why it occurred. Because it doesn't take into consideration, it just looks at this 5 and 5, and then Nina and Prill, they appear in this fashion. They could have appeared in the other fashion as well. So what we'll have to do is, while we sort this, if there is an equal to, like 5 and 5, we'll have to decide whether it should go 110, 109 or the other way. But then there would be a problem because then the sleep hours could also get swapped. But this is an interesting problem. I did not realize this. So you can figure out that we did not read it very well before presenting. But thanks, that's a nice suggestion. And you basically clarified why it got, why that error crept in. Yeah.
Hear me?
Yeah.
I just want to say that I think that Frank was interested to say that people may be interested in seeing that the data is almost correlated. Okay? He was not interested in the bug. He wanted to say that people might want to know, okay, this is almost correlated. Okay? That's also useful information.
Yes.
I also don't know how to indicate it, and maybe Frank also doesn't know. But okay. Then I missed that. Sorry.
Frank suggested that we could have the degree of sortedness, like this is almost sorted, 95% sorted or something, some such number.
My suggestion was to use not a circle with a less or greater sign, but use a circle with a less tilde sign to indicate almost sorted.
Yes.
We sorted by age. That's why there's a diamond. The others have been sorted by chance, if you like. And what I was suggesting, if it's fully sorted by chance, as you do it like the symbol is now, if it's nearly sorted by some measure of nearly, then you have a slightly different symbol in it. So you have the circle, but then tilde greater or something, indicating.
Yeah. So the set of symbols would grow. That just shows how provisional it is. Symbols are not final.
Question here.
You also explained like the keys depend the order of sorting. Wouldn't that also be descriptive then to display the key in the column?
In the count?
In the column.
Yeah, they could appear in the column, or any symbol could appear in any of the columns or any of the rows as well.
Yeah.
But I've just chosen to, for simplicity, I've just chosen to show them as columns.
Can you go back to the previous table? So
Yeah.
was age 1 and then height 2 and then sleep 3?
No. In this case, it is only one key, age. So this has been sorted only on one column, and therefore, trivially, this is the primary key. Trivially, because there is no competition, there is no secondary key, no tertiary key. We have not put a symbol here, but yeah, you could put a symbol of primary key here to indicate that, well, this is the only sorted one.
Okay.
Actually, it would help because it would tell you that these guys, height and sleep, even though they look sorted, they are not the keys. Yes. Point taken. Yeah, you see that from the circle. But no harm explicitly putting it there. Because imagine this is being read out, like your presentation yesterday. There, if you don't have the key symbol here, you might wonder whether the columns on the right, they might be sorted. So you'll have to wait till you see all the columns. But if you put a key 1 symbol here, right adjacent to the H column, then you know that there is no other column that is sorted. Sort has not been applied to any of those columns. Yeah, thanks.
If I understand your mechanism,
Yeah.
your sorts are stable.
Sorry?
Your sorts are stable. That is, incomparable elements are still in the same order than originally.
Sorry, I couldn't follow your accent.
If you sort with an order,
If I sort,
order is anti-symmetrical.
Could not understand you.
Sorry, I could not.
Anti-symmetric order. An
Antisymmetric
order
order.
relation is anti-symmetric. A pre-order is not.
Pre-order is
So,
not.
in fact, if you sort by age, That's not an order, but a pre-order.
If you sort by
Yeah.
age, it's a pre-order, not an order.
Not an order, a pre-order.
You're using a term from lattice theory, pre-order?
Pre-order that is reflexive and transitive.
This is a mathematical
Yeah.
But
term.
not wholly antisymmetric. And in fact, what you are doing is consider a stable pre-order. These incomparable elements
Okay.
are still in the same order than originally.
Yeah, the word order is not being used in the sense of lattice theory. This is just usual order, like some structure. I understand the word pre-order, order and pre-order, they have special meanings in lattice theory. I think you're probably using in that context. Then there is no word pre-order. The word pre-order comes from lattice theory.
Stable order makes pre-order the third order. This makes it antisymmetric.
I'll speak to you after the session.
So the original table order was lost, right? You can't reverse that. No?
Yeah, this was the original table.
So let's say you want to go back.
Go back, where?
No, if you start.
Okay, got it. From this table, you want to go back, you want to retrieve the original table.
So there was an index number or something. Maybe you can go back, right?
Yeah, but why do you want to go back?
Maybe there was some state that needs to be preserved, right?
Oh, but you still have access to this. I mean, this doesn't get lost. You can save them as different things.
Okay, you mean, I thought you were doing on the same thing, no? It's like how you do in Wikipedia data table. You click.
Wikipedia shows the button to sort it. It does not really indicate whether the column has been sorted or not.
Exactly. So there you refresh,
It is like sort this.
there you refresh the page, you go back to there.
Yes. Yes.
So in your
Rajesh.
overall idea,
She
in
wants.
your overall idea, you're saying that you will have a symbol for the columns that are getting correlated, or you will only have symbols for the auto sort mechanism that you're talking about, symbols for sorting.
Both.
So how are you going to specify the correlation between them? Because sometimes it could be direct linear correlation, and sometimes it may not also be there, right? So as the underlying thing is somebody has to look at the data between the sorted columns and make that inference on their own, right?
Right. Imagine you have a very large tables. Okay, suppose this table is very large, not just 6 rows, several more rows and several more columns. Your first thing you want to do is to check which variable is related to which variable in terms of correlation. And then you would do the statistical processing. So this comes before statistical processing even begins. It just leads you to a hypothesis.
Yeah, but what I'm saying is if you have that additional correlation also being indicated, so somebody does not have to take this data again out and plot it onto a X and Y graph and then look at the correlation. That gives you the idea that there is some sort of a correlation there within the data. Then they can go back into the data and do fine tuning or digging more things about it.
So once you detect a correlation, you could add those symbols here. But that would come after do the statistical processing and check whether they are actually correlated or not, and to what extent.
Yeah, what I was saying is because you have the data there and you're auto sorting certain columns, and if you're able to suggest there is an hypothesis and that is already identified and shown as some sort of a symbol, then as a human, I get that idea saying, okay, there is a possible correlation there. So anyhow, this is a table being rendered in TEC, and if that is also being done, so TEC could have that additional power of being an initial case of a statistical processing tool.
Yes, probably. Yes. How much time do we have now?
Okay. How you have a column that you sorted and you know that you sorted it, but for the other columns you don't really know before you are doing some analysis if there's a correlation or not. How would you indicate columns I didn't care or I didn't check? Do you simply leave out the symbol? No symbol, or a symbol I didn't do anything, or I checked this?
Yes, we did that here. So this is unprocessed data with sort symbols. And since we have not done anything, the symbol is here. Not done anything.
But just staying on the same question, you may not actually check every column. If you have a table with 500 columns and you go only sort of what you consider important, there's no symbol to say this data is not checked.
Not checked, yeah.
Might be also interesting to...
Yeah. It's always important to have a symbol for those extreme cases, not done anything. Like the simplest case is 0 in mathematics. Another from set theory is the empty set. You have a symbol for that. So similarly, have a symbol for, that's a nice idea.
Okay, so thank you very much. I want to introduce some discipline.
Thanks.